Welcome back. In this final section, we will look at integration as limit of the sum. Now, it might look rather strange, but we've already looked at adding and estimating the area under the curve with trapeziums. Riemann sum is yet another way of evaluating an integral with with small evaluated either at the left-hand coordinate or right-hand coordinate. In this diagram, for example, the rectangles have left-hand side, their left-hand side evaluated with a function. So all that doesn't really matter. All we need to know is that for A-level maths, we don't need to know the theory behind how the Riemann sum is calculated. All you need to understand is that this, if you're asked to evaluate this limit and you have some function to in front of the summation sign, sigma notation, what it means is that you are adding more and more rectangles within this uh, range of 1 to 2. How do you know there is where to find 1 and 2? The value of 1 will be at the lower end of the sum and the value 2 will be at the upper limit of the sum here. So this lower value will give you A and the lower upper value will give you value for B. Those are the lower limit for x and upper limit for x that we will find from the summation notation there. This limit you don't have to evaluate. All you need to understand is that as we add more and more rectangles, the width of each rectangle will approach zero. So in fact, most of the questions, as you see at the bottom of the page, have the notation dx approaching zero. So the meaning of dx approaching zero is that we are in fact adding more and more rectangles within that same range, or rather that interval. So let's look at this example more carefully. We are, for example, given a function such as function sine to integrate on the but we are not told that straightforwardly. We are rather told that we have to calculate the summation of sine from 1 to 2. Okay? So what that means is that the left-hand side here can be simply written as the right-hand side here. Now, putting dx here means, or rather delta x here, gives you a hint that this summation doesn't involve what we learned in chapter 3 of Pure Maths 2, but it's rather an integral. So pay attention because of the limit in front and this delta x here. What it means is that we are using integrals. So solving sine as an integral will give us the value of negative cos, and we will evaluate negative cos at those two ends. We will have an area of 0.9. Now, as you see in the examples at the bottom of this page, you have to find, rewrite these questions in terms of integral and evaluate them the best way you know you've found so far. We've come across a long way. We've learned into solving integrals with as a reverse chain rule using u substitution and breaking equations involving fractions into partial fractions and so on and so forth. So I'll leave you to practice and I wish you all the best with this course and I hope I see you again in the next section.